In this video, I want to review probability with Venn diagrams. Oftentimes the ACT will give you probability questions and give you a Venn diagram in order to help you solve those problems. I think the best way to teach this is by giving a specific example. A popular ice cream shop has tracked its last 2,000 sales in order to better manage its inventory. The Venn diagram below shows the number of customers who bought chocolate ice cream and those who bought a cone out of those 2,000. So let's analyze the Venn diagram. We have the blue circle, which represents the total number of customers who bought chocolate, and the green circle, that represents the total number of customers who bought a cone. The overlap between those two sections shows the number of customers who bought chocolate and a cone. The number 436 represents the number of customers who got chocolate but didn't get a cone. The number 635 represents the number of customers who bought a cone but not chocolate ice cream, and the 185 represents the number who bought both. Outside of those circles should represent every other customer who didn't buy chocolate or a cone. So let's determine how many that actually was. So we had 2,000 total customers, that was what was given to us, minus the 436, minus the 185, and minus the 635. And that gives us 744. So we have 744 who didn't buy chocolate or a cone. Let's do the first question. What is the probability that a customer buys chocolate ice cream but does not buy it with a cone? So to answer this, we already have labeled how many customers buy chocolate ice cream without a cone, and that is 436. We also know that the total number of customers was 2,000. So the probability that we get a customer who buys chocolate ice cream without a cone is simply 436 out of 2,000, or we can reduce that to a decimal. That would be 0.218. Pretty simple. So the next question, given that a customer buys a cone, what is the probability they get it with chocolate ice cream? So what is the total number of customers who buy a cone? Number of customers who buy a cone. That should be represented by the 635, which is the number of customers who buy a cone without a chocolate, and the 185, the customers who buy a cone with chocolate. So the number of customers who buy a cone ends up being 820. So given that the customer buys a cone, so given that they're one of those 820 customers, what is the probability they get it with chocolate ice cream? So that should be 185 over 820. And if we put that as a decimal, 185 divided by 820, let's round that off to the nearest thousandth. That gives us 0.226. And our final question, what is the probability that a customer gets neither chocolate ice cream nor a cone? Well, when we did our original analysis of the Venn diagram, we determined that 744 customers fell outside of those two circles. So that number, 744, represents the number of customers who didn't buy chocolate ice cream or a cone. And we know that the total number of customers was 2,000. So 744 out of 2,000 should be our answer. So let's reduce that. And we get 0.372. Hopefully that example or those examples helped you better understand probability with Venn diagrams.